LeetCode 1249, minimum removed to make valid parentheses, isn't just string cleanup. It mirrors real challenges in compilers, live editors, and streaming passes where every parenthesis has to match. When scale hits, brute force sinks. So how do we stay both correct and efficient? Let's duck in. All right, ducklings, time to cannonball into brute force. We'll try removing every possible combo of parentheses until we land on one that's fully balanced. We start by calling a helper with the full string, beginning at index 0 and no removals yet. This kicks off our recursive backtrack. Inside the helper, first check if the current string is already valid. If it is, we return it right away. No extra work needed. We'll use a result set to null it first, updating it only when we find a valid string, and ideally the longest one, during recursion. Now we scan from the given index, and for every parenthesis we find, we try removing it. That's our key branching point. Letters don't impact balance, so we ignore those. Our focus is only on parentheses that might be unpaired. To simulate a removal, we build a fresh string skipping the current character. This gives us a new recursive path to explore. We recurse again with the shortened string, starting at the same index, and bump the removal count, even if we're not using it for filtering just yet. If it's our first valid string, or it's longer than what we've seen so far, we update the result, aiming for the least modified version. After exploring all options from here, we return the best valid string we've found along the way. To support that, we need a validator, a quick way to check if a string's parentheses are balanced and good to go. Start with a counter to track how many opening parentheses we've seen so far. This helps us simulate balance. Loop through the string. When we hit an open paren, bump the counter. It means we're expecting a close later. If we hit a closing paren, we check if there's an open waiting. No open, then it's invalid. Otherwise, we consume one. At the end, make sure the counter is 0. Any leftover opens means the string's still off balance. This brute force waddle runs in big O of 2 to the n, over 1 million combinations for just 20 characters. Way too slow for big inputs. Space is big O of n due to recursion and string building. And watch for stack overflow if the input nests deep. So how do we skip the extra work? Let's just find the parentheses that don't match. No need to try every combo. Quack smart, right? To do that, we'll use a stack to track unmatched open parens and a set to store the indices of characters to remove. Scan the string. If it's an open paren, push its index onto the stack, hoping to match it with a close later. If we see a closing paren, check the stack. If there's a match, pop it. If not, it's unmatched, so mark it for removal. Once we're done scanning, any indices still in the stack are unmatched opens. Mark those too for removal. With all the bad indices marked, we build a new string, skipping anything flagged and keeping the rest. And that gives us a cleaned up string with only valid parentheses and untouched letters. Excess trimmed. This runs in big O of n, just 2 full passes. About 200,000 operations for 100,000 characters. Space is big O of n for the stack and set. It uses more memory than necessary but wins big on speed and clarity. How do we push this further? That stack and set still use space. What if we mark invalid parentheses directly inside the string? Let's go in place. First, we convert the string into a character array. This lets us mark and skip invalid characters without extra structures. Now we'll set up a counter to track unmatched opens. It helps us ignore stray closing parens as we move forward. We scan left to right. Every open paren we find increases the counter. We're expecting a closer later. If we hit a closing paren with no unmatched open, we mark it as invalid. No point keeping it. But if we have an open waiting, we match it and drop the counter. Balance restored for that pair. Once that's done, we scan backward to remove extra opens that were never matched, trimming the leftovers. Now we build the result by skipping marked characters and keeping all valid ones in place. That gives us the final clean string, with all invalid parentheses gone and everything else intact. This solution is clean and fast. Big O of n time. 2 simple sweeps over the array. Space is also big O of n for the char array, but no stacks or sets. It's a production-ready answer and an interview win. We started with brute force, checking every option, but drowning in exponential time. Then we leveled up with a stack-based filter. But the real boost came from the 2-pass scan, lean, fast, and scale-ready. In production systems, this method shines when millions of characters need validation. It trims waste, avoids overhead, and keeps logic tight. For FAANG interviews, this shows more than coding. It shows optimization. So ask yourself, could you solve this without any extra space? Or make it work in a stream? Keep pushing forward, because every clean solution starts with a smart idea and a debugging duck by your side.